In this video, we're going over course schedule 2. So there are a total of num courses you have to take, labeled from 0 to num courses minus 1. You're given array prerequisites where the prerequisite at index I is equal to A and B, indicate that you must take course B before you can take course A. For example, the pair 0 and 1 indicate that in order to take course 0, you have to first take course 1. Return the ordering of the courses you should take to finish all of the courses. If there are many valid answers, return any of them. If it's impossible to finish all of the courses, return an empty array. So in our first example, we're given this num courses and the prerequisite is 1 and 0. This means we need to take course 0 before we can take course 1, as we can see here. And then we are able to take all of the courses. So we just return the ordering of the courses that we have taken. Let's go over the dot process. So we will be implementing the concept of topological sort. Each of the courses can be represented as a node inside a graph. Now, for example, if we have the courses X and Y and Y and Z. In this prerequisites, it means we have to take course Y before we have to take course X. So we can draw an edge, a directed edge, from Y to X. Now in this prerequisite, we have to take course Z before we have to take course Y. So we can draw a directed edge from Z to Y. Now our graph becomes Z to Y to X. Now, based on this, it's pretty obvious that we have to take course Z first. But why can't we take course Z? Because there are no incoming edges to Z. If there are no incoming edges, this means there are no prerequisites. And if a course has no prerequisites, we can just take the course. This means all of the nodes with an integrity of 0 can be taken. Let's go over the pseudocode. So we're going to create a custom class, node, and there will be two fields. The first one is neighbors, list of neighboring nodes, nodes/courses. They actually mean the same thing, and also need the integrity, the number of incoming edges. Now we're going to create an array of nodes to keep track of all the nodes. So the indices represents the course ID and the values represents the nodes. Then we're going to iterate through the indices of nodes denoted as ID is the course ID. We're going to set a new node at nodes ID. Now we're going to iterate through the prerequisites denoted as pre. Now we want to draw an edge from pre1 to pre0. So I'm going to add pre0 to nodes pre1 dot neighbors. Now we want to increment the integrity of pre1 or pre0. Increment the integrity of pre0. So this is basically saying we currently have this, so we add X to the neighbors of Y, and then we want to increment the integrity of X because there's an incoming edge coming through. Now we want to find the ordering of the courses, and in order to find the order of the courses, we have to start with the courses without prerequisites. So we're going to create the following variables, and we're going to have courses, the ordering of the courses, and I, the current index we are populating inside courses, and also our queue to process all of the courses that we can take. Now we're going to iterate through nodes, the indices of nodes denoted as ID. We want to start with the courses with 0 integrity. So if nodes ID.integrity is equal to 0, This means we can take the course. So I'm going to add ID to queue. Now, while queue is not empty, we're going to process all of the courses now. We're going to pull an ID from queue. Then I want to set courses at index I to ID. Then I want to increment I. Now we want to go through all of the neighbors of this course and decrease the number of in degrees because we have already processed. So for example, if we currently have y to x, if we have processed y here, we want to remove this edge. And after we have removed this edge, the in degree of x is equal to 0. This means we can take the course now. Then we iterate through the neighbors of ID, denoted as neighbor ID. Now we want to decrement nodes neighbor ID dot in degree. Now if the in degree is equal to 0, this means we can take the course now. There are no more prerequisites. So I want to add neighbor ID to queue. Now, if I is equal to num courses, this means we have taken all of the courses. We can just return the ordering of the courses, else we can return an empty array because we have failed to take all of the courses. If I is equal to num courses, this means we have populated all of the indices. Now let's go over the time and space complexity. For the time complexity, we get O of n plus e plus O of n, and then plus O of n plus e. Where n, e are the number of nodes and edges. This one is initializing the nodes array. And then we're going to find all of the starting courses without prerequisites. And then we have processed all of the nodes and edges. In our space complexity, we get O of n plus e plus O of n plus O of n. So we get O of n plus e. O of n plus e, we have the nodes array. And then O of n is the courses. And another O of n is the queue. Now let's go over the code. So we're first going to create our private class. Node is going to have a list of neighbors. And also have the number in degree, initially 0. Then we're going to have a constructor initializing the neighbors list. We will first create our array of nodes using num courses and prerequisites. We're going to initialize each of the indices, basically populating a new node at each index. Now we want to connect each of the nodes using the prerequisites. We want to add an edge from pre1 to pre0. So nodes pre1 dot neighbors dot add pre1 pre0. Now I want to increment the in degree of pre0. Then we can return nodes. Now I want to process all of the courses. We're going to create an array courses to keep track of the ordering. We're going to create an index I to keep track of our current index we are populating inside courses. And then we're also going to create a queue to process all of the courses. We're going to start with the courses that does not have any prerequisites. Now we're going to process all of the courses while the queue is not empty. We're going to pull an ID from the course or from queue. Then we're going to populate it inside our courses. Do not forget to post increment our index I after we're populated. And then we're going to iterate through the neighbors of the current course. After we have processed the current course, we want to remove the integrity inside our neighbor. So we want to decrement the integrity. So nodes.neighbor ID.integrity minus minus. And now if the number integrity of the neighbor is equal to 0, this means there are no more prerequisites. If there are no more prerequisites, we can take the course. Now we will check if I is equal to num courses. If I is equal to num courses, this means we have taken all of the courses, so we can just return courses. Else we have failed to find all of the courses, or we have failed to take all of the courses, we can just return an empty array. Initializing array here. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.